We've determined that if the charge Q1 at negative 3 meters, 2 meters, acts on a charge Q2, Q1 4 millicoulombs, Q2 negative 2 millicoulombs, Q1 acts on Q2, and with this charge at 10 meters, 7 meters, we found that the force is negative 350 newtons times I minus 135 newtons times J. The question I'm going to pose now is, what if Q2 was replaced by a plus 0.006 Coulomb charge? Same point, we just make it 0.006 coulombs and it's positive. What would the force now be if Q2 was instead this charge? Okay, hopefully you paused and worked that out, and hopefully if you worked that out, you didn't go back to Coulomb's law. Now, well, we can go back to Coulomb's law for a minute. We got F equals K Q1 Q2 over R squared times R12 over R12. Okay, now we could go back to this same calculation and we could get the correct answer, but R12 is the same as it was originally, so this, and this are all the same. K is a constant, and Q1 is still the same. So the only question we really need to ask is, what's the effect of Q2? How did we change Q2? Well, it should be clear that Q2 tripled and changed its sign to positive. What would that do to the result of the calculation? So work that out and see if you haven't already done so. I'll be back in just a moment. Okay, well, Q2 changes by a factor of negative 3. If we multiply this Q2 by negative 3, we get positive 0.006 coulombs. That should be very easy to calculate and to understand. What's that going to do here? Well, Q2 is a factor of the calculation for F, and everything else is the same, so that's going to change the force F, and that would be F12. That would change the force F12 by factor negative 3. So what's the new F12? Well, Q2 being a factor of the calculation for F12 means that if Q2 changes by a factor of negative 3, F12 changes by the same factor. So their new F12 will be negative 3 times our old F12, and if I did my calculations correctly, which you should check, we get 1,050 newtons plus times I plus 405 newtons times J. Well, we could do the same thing for any Q2. For any Q2, we could multiply the original by the new Q2 over negative 0.002 coulombs. So that means we could multiply this negative 350 newtons times I minus 135 newtons times J times the new Q2 divided by negative 0.002 coulombs. What we just did. If we take the new Q2, which is 0.006 coulombs, and divide by negative 0.002 coulombs, that's where we get the negative 3 that we multiplied by the old F12 to get the new F12. Okay, and the point is there's no need to go through the entire calculation using Coulomb's law, using this law, because everything is the same except for Q2. That suggests an even better way to accomplish the same thing. I'm going to let E be F12 divided by Q2. When we divide this expression by Q2, we retain everything that we used in calculating F12 except for the Q2. If we let E equal F12 over Q2, then we're going to be able to use that to calculate the force at this point for any charge that we want to put there. So let's do that division. What do you get if you divide F12 by Q2? Okay, well, I'm going to continue on. You should pause. You should have already paused and gotten your expression for E. But that's pretty straightforward. E, of course, we could write it out this way. K Q1 over R12 squared just eliminates the Q2. But and we'll do that also, but I'm really thinking of this, so that the F12 vector is going to be negative 350 newtons times I minus 135 newtons times J, and then you should have done this, divided by your negative 0.002 coulombs. Okay? And hopefully you've calculated that. If you haven't, you should calculate it. That's going to equal, well, dividing by 0.002 is the same as multiplying by 500. Okay? And 300 times 500, well, 350 times 500 is 175,000, I believe. So that's 175,000 newtons per coulomb times I, plus 5 times 135, 650, 675. So I think that's going to be 67,500 newtons per coulomb times J. Now, this is what we call the electric field. Okay, I used E for this. This is the electric field. Let's see. Electric field at 10.7 due to the charge of 0.004 coulombs at negative 3 meters, 2 meters. Okay, I'm going to write that in off camera, and then we'll wrap this specific video up and go on to another one. Okay, I've written that in. Electric field at 10.7, and of course I haven't put the meters in there just for space reasons, but it's understood that's 10 meters, 7 meters, due to the 0.004 coulomb charge at negative 3 meters, 2 meters. Now, we're going to verify that this is useful. Let's go ahead and multiply this electric field by 0.006 coulombs and see if it comes out with this result.